Welcome back. Let's do this. All right, so I got to start with a hopefully minor logistical note. I don't know. Oh my goodness, I still have a typo, don't I? I still have a typo at it. I fixed it. Hopefully minor logistical note. I can't foresee anybody getting too upset, but if you do, let me know. You can complain to me. I deserve it. But I had a typo in the syllabus. I have my personal policy. Day one, syllabus is released. We have day one of classes, and that's my contract to you. I can't change anything on it. But I had a logistical typo. I said there are 10 learning objectives in the course when there's actually 12. I said there are 3 on each of the first 3 homework assignments, and then also the first part of the project. But the first part of the project is actually 3 learning objectives, so I had to change this from 10 to 12. If you do see that change, I just want to get ahead of that. So you don't say, holy crap, it changed from 10 and now it's 12. You do have to complete all of them, and there are 12 total. I still have a typo. I still messed this up somehow, and it says 10 right here. It should say 12. When I wrote this, I was thinking of the first part of the project being 1 learning objective, which if somebody really wants to hold me to it and say, no, you said 10, then all 3 objectives of project 1 combine, you pass them all to earn 1 learning objective would be the way I'd kind of lawyer my way out of that one if I have to stick to the original syllabus. So I just want to point that out in case anybody does notice and does get upset at that one, which I don't know. I don't know if you would or wouldn't, but I wouldn't be mad if you did get upset with me. The syllabus is, this is what the course is going to be. I don't take changes to the syllabus lightly. Unless it makes things easier, then nobody complains. But this didn't change anything that you have to do. It was just the way I presented it in the syllabus was a little bit off. All right, homework 3 and project part 3 are out, as well as homework 4. Project part 4 is going to take me a while. There's a lot that I have to do. It's a lot different from last semester, so there's a bit for me to do here, but I'll want to get that one out fairly soon too. Project part 3. I just want to talk about this briefly so we can get into some content. Man, the internet's been slow today. I need these things loading faster. Let me get homework 3 loading at the same time. So project part 3, this is where where most of the app is going to be created. This is where it becomes your app. Project part 1 and 2, part 1 is, you know what part 1 was. Just kind of getting warmed up to the idea what the project's going to be. Part 2 was getting with your group and getting the foundation of it laid out, getting your framework set up and doing some basic things. Part 3 is where it's going to come together, and this is where you're going to choose what your app is going to be, choosing between one of these 3 categories. These categories are intentionally pretty broad, a game, an auction house, or a quiz app. So hopefully if you have an idea that doesn't exactly fit into one of these 3, that you can make it fit in. If you're having trouble doing that and you have an idea your team's really excited about, let's talk about it. I have one team who emailed me already and we're in discussions. I think we can get theirs looking like the quiz app and meeting the criteria. But whatever you do have to meet the criteria of one of these 3 categories, which for this one is going to be adding images to your posts. And I have the criteria laid out for each one of them. It's going to be slightly different for each one. So, discuss between your team which one you want to go for. I think they're fairly balanced, but we'll see. Whatever one ends up being what half the class does, I'll know that's the easiest one. But, I think they're fairly balanced. But the difficulty is different for each one. Well, that came out wrong. What I mean is there's 3 objectives, and objective 1 might be easier for one of them, but objective 3, that's where the difficulty catches up. But average across the 3 objectives, I think they're fairly well balanced. I could be wrong, but I think they are. Number 2 is adding WebSockets to your app and having interactions through WebSockets, which do include some sense of timing for each one of these. There's some idea of timing. Like for the auction, the user posts an auction, says, I want this auction up for, say, 5 minutes. And then every user needs to see the live clock clicking down. And then after the clock time expires, they can't make bids anymore. So, for example, that for some sense of timing. And then objective 3, kind of finishing out your features of your app. For the game, this is actually making the game. For your auction, keeping track of who won each auction. For the quiz, keeping track of the grade book. And then that's part 3. So it's a lot of building your app. If you're having trouble getting your app idea, if you have a pre-existing idea, I don't want to discourage you from having an idea you're excited about and working on it in this class. But so we can talk about that. But it does have to, at the very least, meet the difficulty still has to be there. I don't like saying it that way. The objectives still need to be there. Like, I want you getting practice with image uploads and WebSockets. That's what Project Part 3 and Homework 3 are all about. That's the thing that you're actually learning in this part of the course. So those things have to be there and have to be fairly complex to make sure that you actually get practice doing those things, working with a framework. So that's what I'm looking for if you want to deviate slightly from these. The level of understanding you need has to be at least the same level as these 3. For those you apply to. Hopefully it's not too many groups, because never mind. Actually, I don't care. I'll do more. It's more work for me, but I'm excited to see projects you're passionate about, so I wouldn't mind it. All right, so that's Project Part 3. Take a look at that at your leisure and take a look at everything that's required there. And then Homework 3, this is doing the same things mostly, but without frameworks, just like the first 2 homeworks. But the requirements are starting to deviate a bit because the project is getting more specific and the homework is also very certain things. So let's talk about it. In Homework 3, I want to give this disclaimer up front. Homework 3 is going to be significantly harder than the first 2 homeworks, especially Homework 1. Homework 1 is like an intro to the course in setting up Docker in a basic HTTP. Homework 2 was warming up a little bit, but Homework 3 is where things are getting real with the course. This, in my mind, like kind of my vision of how I look at the course, Homework 3 is like the capstone of the course. Like, this is your final test of your understanding of all of these concepts. That's where everything comes together, and you really have to understand everything that we've been doing so far to get this one done. And it is going to be a lot. Do not take Homework 3 lightly. It's going to be intense. There's a lot going on with this one. But Homework 4, I think, is fairly trivial. The Project Part 3, since you get to use a framework and have a whole team of people working on it, should be a lot easier than Homework 3. And then Project 4, I don't intend to be very difficult. It certainly won't be a step up in difficulty from Part 3. I don't think, anyway, in my opinion, I should say. So Homework 3, it is going to hit hard, but it should be the last hard hit of the course. So I just want to get that out there so we're all on the same page right up front about it. And this is the difficulty curve I like to build into my courses. If you took 116 with me, you probably heard me say the same thing. Is the course kind of eases in. You have this gentle ease into the course, and then things start getting difficult, but level off a bit. And then towards the end of the semester, it drops off. I want the last thing of the semester to be easier than that thing that's at like the 75, that 3/4 point of the semester. That's where the hardest stuff should be, is at the 3/4 point. If I design the courses the way I want them. The reason for that is at the end of the semester, that's where every course wants to hit you the hardest. So that's where I like to back off. I'm going to take your time at that halfway to 3/4 mark of the semester. That's where I want to give my biggest challenge, and then I'll back off and let you work on your other courses after that. So that's the design. Sometimes I hit it, sometimes I miss it. I think I got it in 312 this semester. Feel free to give me feedback on that if I did miss it, especially. And I can adjust for next semester. So let's talk about what we're actually going to be doing. Image uploads, this is what we're going to talk about in today's lecture. After today's lecture, you can do Learning Objective 1. I'm going to put everything out there for Learning Objective 1. We should have time to get through all of it. And then Wednesday, I'm going to reinforce what we talk about today through testing techniques, which will contain a lot of examples of image uploads and showing you exactly what can go wrong, what to look for, to help you with this objective, just like tips and tricks kind of thing. But today is going to be everything that you actually need. And it's going to be a form where you can upload a profile picture. So somebody can register and log in to your account, and once they're logged in, they can upload a profile picture, and wherever that eagle is on the page, where that eagle is, that should be replaced with their profile picture after they upload one. So that's that feature. Then changing chat. So chat uses Ajax and polling right now. Changing that to use WebSockets. That's all I got to say about it, I guess. I thought I had more to say. That it really is the way I changed it. That chat history path still needs to be active, but you already have that from homework 2. One of the advantages of having learning objectives, like you have to complete each homework, I can actually depend on previous homeworks. Usually I avoid that to avoid cascading failure, but you have to do them all. So we can rely on that one for what it's worth. WebSockets, we're not going to talk about those. We're not going to start talking about until Friday, but we're going to do 3 days of WebSockets to get you up to speed on how to do those. And then buffering. This doesn't actually add any brand new concepts, I guess. It's building on to learning objectives 1 and 2, but allowing arbitrary size images to be uploaded and arbitrarily long chat messages to be sent, up to 131,000 bytes for chat messages. There's a certain thing that Chrome does after that I'm not going to get into right now, but we'll talk about it when we talk about WebSockets. And arbitrarily large image files to be uploaded. So making it big for learning objective 3, which hopefully is easier than the first 2. I assume it would be if you did the first 2 really well. And then the application objective is video chat over WebRTC. We have a whole week of this. So everything that you need for the learning objectives, I'm going to cover in 2 weeks. And then that third week is going to be all about the application objective, where I have a lot to talk about in lecture with WebRTC, but actually doing the application objective, in my opinion, isn't all that difficult. So it's one of them topics where there's a lot to talk about in lecture, but not a whole lot for you to do on the homework. So I think that's kind of a nice cool down after 2 weeks of intense material where you do have to do a lot in the coding. So that's the application objective. But more importantly, after 2 weeks, you have everything for the learning objectives. So you effectively have that extra week to get the learning objectives done for this assignment. And yeah, that's homework 3. Let's start some content and teach you how to do that. Any questions up front? What's up? Oh. Homework 3 and Project 3, can we use any framework or just build Project 3 on top of Project 2? For Homework 3, any of the homeworks, you cannot use frameworks. That still applies to Homework 3. For Project 3, you can use any framework. It has to be one of the approved frameworks in the, where did that even end up? In Project Part 1 handout? Is that where the list ended up? Is that the only place I have that list? Yeah, I think so. It has to be one of these frameworks, or if you want something that's not on that list, send me an email, let me know, and I'll make a decision whether it should be added to this list or not. But one of those frameworks, and yes, you can switch from Project 2. Project Part 2, you use Django. You decide you don't want to use Django anymore. You want to switch to Flash for Part 3, go for it. I'm not going to restrict changing frameworks whenever you want. Would you say Homework 3 is the malloc of 312? Quite possibly. Homework 3 is going to hit hard. I can't stress that enough. It's especially looking back at, now that Homework 3 is out and I look back at Homework 2, it's a big step up. There's a lot for you to do. Oops, wrong button. There's no sugarcoating it or anything. And to clarify, I think it's going to be the hardest homework. I don't think anybody's going to disagree with that. But if you really did everything in homeworks 1 and 2 very well, you have very good organization of your code, you understand those concepts, you really know your stuff, those 2 homeworks, homework 3 won't be as bad. It won't be like a huge step up in difficulty if all of those, but if, like a lot of you have all of your code in the handle method, and if, else if, or elif because it's Python, elif, and no helper methods at all, no helper classes except the request class, because I had that in the handout. If your util package still just has request and nothing else, no organization, homework 3 is going to absolutely kick your ass. There's nothing I can do to help you at that point. If you've refused, like we teach OOP in 116, and then unless you're forced to use it, some of you just won't use it. And testing, some of you just won't test if you're not forced to test. I can't help you at this point. It's a 300 level class. There's nothing more I can do for you. All right, let's get into content. Y'all are talkative today. I say homework 3 is going to absolutely crush you, and you're like, I'm not even going to listen to the lecture. It's going to hit you even harder if you're chatting instead of listening. And I also can't help you with that. I can't help you. All right, so let's revisit HTML forms. So last time, this is what forms looked like. Pretty fresh in our memory. Homework 2 was just due this morning for the expected deadline, so it's really fresh in your memory right now. This is what we had for the registration and login forms. If you used my handout code verbatim, you were allowed to change those. So if you did change them to use Ajax or something, maybe you didn't see this, but this is what you were parsing if you used my forms, which I assume most of you did. We'll know after doing some grading. We had this form, send it to a certain path. We used post, and we got requests that looked like this. We had URL encoded messages that look like query strings. It's the same format. Query strings are made to go in URLs. It's URL encoded. And this is fine. This is the default encoding type that you'll get if you don't specify an encoding type. But we can specify an encoding type in our forms. And by default, this is what we get. Is the same as saying encoding type application XW. I don't know if I've ever said this whole thing. XWWW form URL encoded. I just call it URL encoded. But if it's URL encoded, this is the encoding type you get. If you don't specify what, and all your special characters and non-ASCII characters, anything that's not a valid character in a URL is going to be percent encoded. You've seen this on the homework. I don't have to talk about it too much, but when we're going to do something different, this isn't going to satisfy what we need to do. First of all, the URL encoding, I don't know, it kind of looks gross. It's not the prettiest format, but that's not that big of a deal. If you have a library that's going to handle that for you and decode it, it's not the biggest deal. But where we're really going to run into trouble with this is that we need file uploads. We need to upload files, and files will not be URL encoded. We absolutely can't use this for file uploads. The browser will not do it. Technically, theoretically, it could do it. It can percent encode every single byte of the file and then dump it all in a URL encoded string like this. It could do it, but it doesn't. It won't do it. It's not what the browser is supposed to do. No browser is going to do it. If you try to upload a file using URL encoding, it's only going to give you the file name. You're going to get the name of the file that the user is trying to upload and none of the actual bytes of the file. It's not going to work. It's not going to do what we want it to do. So we need something else. We have an actual need for a different encoding, and that encoding is multi-part form data, or I'll just say multi-part encoding. Multi-part requests is what we need to start handling. When we use multi-part form data as our encoding type, this is going to send files. Browsers will actually send the contents of a file with this encoding type. If you've done web development before that needed file uploads, you might have noticed this. You have your forms, you have your endpoints, you're using your framework, and you need a file upload, and the file just never gets sent. It's just the file name until you do some searching, you find a post on Stack Overflow that says, oh yeah, add this to your form, and it'll magically work, and then it does. This is why. The browser will not send a file, the bytes of the file. Hopefully that applies to at least one of you, so I didn't just waste my breath on that one. But this is why. This encoding type, if you don't have that encoding type on your form, the data of files that are uploaded will not be sent to your server. It won't even be sent. There's no way, no matter what code you write in your server, you're never going to extract those bytes because the browser never sent them. But with this encoding type, the browser will happily send the contents of a file. So this is the encoding type we need for file uploads. With multi-part, as kind of the name implies, each part of your form is going to be a different part of the request that's sent to your server, and we're going to get requests that look like this. We're going to get the headers, just like we would normally see, headers and key value pairs and stuff. We're going to see a different content type here, and then the actual content. So here's our blank line that says this is the start of the body, and then the body is going to have these boundaries, which we can read from the content type, and the boundary is going to separate each one of the parts of the body, and each input of the form is going to have a separate part. So where before we had the query string looking thing, the URL encoding with commenter equals Jesse, comment equals good morning with percent encoding here, now we're going to see each part, which is going to look like its own HTTP request with its own headers, its own blank line, and its own body containing the actual message, the actual content that we need to upload. This is a very powerful format because we can do lots of different things with this. We can have data. I have it on a slide. Right here. We can have different types of data. Like if I have ASCII here, UTF-8 here, and then a third thing that should be JSON encoded, I can have all those in separate parts and then have my content disposition and content type telling me about the different content of each part. And more importantly, more to the point of what we're going to do, what we're going to use it for, is when part of this is text and part of it's a file. Actually, I don't have you sending text with files this semester. It's just the files. But you're going to have a part that's files, and you're going to have the bytes of a file here, along with all this text information. We can do that with multi-part form encoding. So to upload files, we need multi-part form encoding, or else files won't be sent. And then to handle file upload on the front end of a site, to build a form that allows users to upload files, we change the type to file on an input, and we're done. That's it. It's not that hard. Right? The browser takes care of everything else from here. We change the input type to file. I'm going to change the name just because calling it comment didn't make sense. So I'm going to change the name to upload. And that's it. I now support file upload on the front end. Of course, we have tons of work to do on the back end when we get these requests to be able to parse them. But the browser does the rest. This will give you the file picker. Users will have the button to click to be able to choose a file. The browser will open up their file system. They'll be able to browse all their files, choose their file. All of that's built into the browser. You don't have to build that in the front end. That's why any site you go to that has file uploads, you always get the same file picker. It's because that's part of the browser. And if you switch to a different browser, you might get a different file picker. It might look different if between like Chrome and Firefox, say. You might get a different file picker because that's part of the browser itself. All you have to do as a web developer is change the type of your input to file, and the browser will do the rest. So building the form is easy. And for homework 3, it's specified throughout the document, but there is new code in the repo for the front end. So if you want the front end code, if you don't want to build the front end stuff yourself, for this it's easy enough, but just to make sure we're on the same page of what's expected for each part of the project, you can grab that new front end code where this will be done already. And then we get these requests. And for the lecture, there's going to be a comment, text and the image. For your homework, it's just going to be the image, so it's trimmed down a little bit in an attempt to make homework 3 not completely soul-crushing. There's not 2 pieces of information you have to parse out. But this is what we're going to get. We're going to get something that looks like this, where the content type, again, this is just like an HTTP request. We're going to have any number of headers here. The content type is going to tell us what type it is. That's obvious, ain't it? But we're going to have content type. We can have content type headers. That's what I'm trying to say. You know the rest. Where this is an image, and then the content for that part is going to be the actual bytes of that image. And this is what we have to parse. That's objective one. Parse these things. Yeah. It can just be JPEGs. So if it, I did PNG. Just when I generated this example request, I happened to click on a PNG to generate the request for the slide. But for the homework, if you only handle JPEGs, if you use the sample images still, that'd be fine. When sending images, we had to be careful never to convert the bytes of that image to a string. We all are very familiar with that, right? Same is going to apply here, but it gets a lot trickier. So now we have the same situation. We're receiving the bytes of a file, but those bytes are surrounded by a lot of UTF-8 text that we need to parse. Like, we have to check that text to see what it says to know how to parse the bytes, specifically where the bytes are. And we have to do all this while never converting those bytes to a string. We have the UTF-8 strings, which is an algorithm that encodes textual data. We went over the algorithm and everything, or not the algorithm, but went over the continuation bytes start with 1, 0, and leading number of ones. And if the first bit is a 0, the next 7 is an ASCII character. We went over all that. It's a very specific encoding, which is very different than JPEG that you're going to see on your assignment that you'll handle for your uploads. JPEG is a completely different encoding. It's still bytes. That's about where the similarity ends. Those bytes can be encoded in any way that's valid JPEG, which is not going to be some number of ones in the first bit and then that number of continuation bytes all starting with 1, 0. We're not going to see that exact pattern in our image files, so we have to make sure that we do not convert them to strings, even though they're surrounded by string data that we have to parse and decode. Well, not necessarily. We actually don't have to decode it. That'll be part of when we go through parsing. But we have to interpret that other information as text with this image sitting right here. So how do we read all of this text, all of this, while never converting this to a string? That's our task. That's what makes objective one difficult, is extracting these bytes to the image while parsing all of this text, all this surrounding text. That's what we need to do. So let's walk through it. Let's go through this step by step and talk about what you're expected to do on the homework. Let me check the Dark Souls of programming. It's the Dark Souls of 312 at least. I mean, there are other entire courses that are harder than homework 3. It's just as hard as 312 gets. Their TAs specifically, they'll always tell me, like, 312 is still easy compared to other 300 and 400 level CSE courses. And they try to talk me into making it harder. How to control a file has a virus. I mean, for our homework, for this course, we're not going to worry about that. I mean, actually, we will. Actually, no, I take that back. We do. We do that with the no-sniff. So if the file has, like, you're going to treat it as an image file. You're not going to run it, execute it as a program. And when you send it to your users, you're going to set the no-sniff, so it's only ever treated as an image. If you have a file that has a virus in it and you're only treating it as an image, I mean, maybe some really sophisticated hacker can somehow get something in there, but your average hacker isn't gonna be able to get that code to execute on your machine when you're only opening it in a file, a file program. Yeah, exactly. Don't run the file. Yeah, you're never taking an image and saying, let's execute this as an exe. You wouldn't ever do that. And as long as you're careful about your file types, you wouldn't do that. Okay, so let's go through this. Any questions so far, by the way? Because this is really the crux of it. This is objective one. You're going to get requests that look like this, You got to parse them, save these files to disk, and then host those files. All right, let's go through it. So on your server, you have all kinds of paths. You already have a whole bunch of paths. And by the way, the else if thing, part of it, that wasn't what I was picking on. A lot of you should have elif, elif, elif. But preferably, if you're going to do that, elif, path equals this and method equals this, then call this helper method. And let that helper method, preferably in a different file, do the work. Those of you who have everything in one file, that's the part I'm picking on. Mostly because I see it in office hours, and then you expect me to parse through 1,000 lines of code that's not organized at all, and I just can't help you as much if that's what your code looks like. Anyway, all right, I don't want to dwell on that, but it's everyone. Don't get me wrong, it's everyone. Anyone who's not doing that doesn't need office hours. I'll say that, but it's because I don't know. Let me actually cap out that conversation a little bit. Like, you're not really expected to architect code often. It's always done for you, and then you get to the higher level classes, then we just expect you to be amazing architects. It's too much of an expectation, but I don't know where you're supposed to pick that up, aside from doing it the wrong way and then just learning over time to do something different. So in 312, that's just where you do it the wrong way and start thinking maybe there is a better way. I mean, maybe that's just part of what you get out of 312 is do it the wrong way and understand how torturous it is when you have over 1,000 lines of code in one file, and then hopefully doing that in a few courses, getting the idea that there's a better way, that you maybe revisit that OOP thing. Or at least, even if you don't do OOP, some people don't like OOP, but at least modularizing your code into separate files and keeping things organized. Writing helper methods and calling those methods multiple times. A lot of those things really help you a lot. Like, I couldn't imagine not doing that stuff in my code anymore. Oh, and go to make open source, yeah. All right, so you'll get a request like this. It's going to start similar to what you've done before. You want to check the path and method, but even that gets a little trickier at this point. That I'll talk about in a second. Check this, but when the method and path is where you expect an image to be uploaded, you can assume, at least for this course, and actually probably out there in industry too, if you get a request for the right path and method, you can assume that it's going to be a multi-part request. Maybe in industry you would want to check the content type, make sure it actually is a multi-part request, but you can make some assumptions. If it's for that path, don't trust your users. They might not be sending the right format. They can change the front end, but in a case like this, like, their stuff would break. That's not that big of a deal. When it's a security issue, that's when we're never trusting our users. But if they break the front end and their profile image isn't uploaded properly, that's on them. They're not breaking other people's functionality. So we're going to check this. It's the right path and method. We assume that it's a multi-part request containing an image. For our homework, containing a profile image. That should be a JPEG. And then we can move on to the next thing, the content length, which is going to be critically important starting on this homework. Content length you probably haven't even read ever. You would parse the header because you have your header parsing code, but you probably never actually cared what it was up until now. But we are going to start caring about this a lot when it comes to image uploads. A lot of this conversation will have to wait for the buffering lecture, which I think is next Friday. I might sneak some buffering content in earlier because it's really important to get that in. There, I'll probably talk about it right now, actually. Content length. You're going to read this content length. This number. This is for a fairly small image, 10K, and you'll notice that number is larger than your buffer in your receive method. A lot of students will say recv, the recv, and then the number. That's just short for receive. I don't know why they like to delete random letters, but that's the receive method. Receive up to this many bytes from the TCP socket is what that method is doing. So if there's 9,937 bytes waiting on that socket to be read, you're going to read up to 2K if you left that 2048 in the handout code. You're going to read at most 2048 bytes of that information, which means if this is your request, receive is not going to give you the entire request. It's going to give you the first 2048 bytes at most of that request. Sometimes it won't even give you that much for reasons that I'll explain right now. No, I think I'll wait a little bit. But sometimes you won't even get that much. It's up to 2048. So we have to address that somehow. When we have requests that are larger than our buffer size, I'll save most of the conversation for the actual lecture on it. But for now, we will have to think about that. Let's just foreshadow that a little bit. I did put a very small image in the repo. It took me a while. I took the elephant and compressed the hell out of it to get it really small so it's less than 2048, that the whole request will come over in one go. So you can at least use that for testing Objective 1 before you have buffering. So you do have a small image to test with. But that won't work in Chrome. I will talk about it right now, I guess. That won't work in Chrome. When you upload an image in Chrome, what it does is takes the headers and sends the headers right away. And then it reads the file, processes the body, and then sends the body. So receive, the first read, is only going to get the headers in the blank line. So it's going to be less than 2048. And then you call receive again to get the rest of it. Firefox doesn't do this. So what I recommend is Objective 1, Learning Objective 1. Test it in Firefox with that tiny elephant image. And that will let you work on your parsing code without having to worry about buffering yet. But then on Objective 3, of course, that's the buffering objective. That's where you have to handle arbitrarily large files and handle this, even when this is in the megabytes, handling that in a robust way. It's important. And then content type is going to be multi-part form data. And then we have this syntax. This is the same syntax we used to specify UTF-8. We did charset UTF-8. Same thing, a semicolon, and then additional directives. Same thing with our cookies as well. We've seen this format quite a bit. Semicolon, and then boundary equals, and then the value for the boundary, which is going to be the boundary between the parts of our multi-part request. So we actually want to parse this content type, look for that semicolon, look for the boundary equals, and extract just the value for the boundary and get that boundary to be able to use to split up the request. And we want to use that boundary to chop up the parts. For your homework, you're only going to have one part, again, but to get everything before the part gone and everything after the part gone, so you just have the part itself to process, which looks like an HTTP request. You should be able to reuse some HTTP request parsing code to be able to handle this. The only difference is there's no request line. You don't have that first line, but you should be able to use your header parsing code, your code that splits the headers and the body to get the body out of there to extract this data. The boundary, if you're looking very closely at it, is not actually the boundary from the content type. It's that boundary prepended with 2 extra dashes. And the boundaries usually start with a bunch of dashes already, so it's a little hard to see, but there's 6 dashes here and 4 dashes here. That's not a typo. That's part of the spec. And the boundary itself doesn't have to have dashes. That's not part of the spec. But when the boundary shows up in the body, it's going to be preceded by 2 dashes, and it will always be preceded by a CRLF. So the boundary is always going to be at the beginning of a line. So when you're parsing, you don't have to look for a boundary in the middle of a line or at the end of a line. It's always going to be at the beginning of a line. So each boundary here, like this boundary, is preceded by an additional CRLF. So we have the bytes of this file, a CRLF, and then the boundary. But for the first boundary specifically, the CRLF, it's already preceded by CRLF because there's 2 of them right here. So this one won't have an extra CRLF attached to it. But that's what the full boundary is. So that's what you want to look for in your parsing. Make sure you don't have these extra 2 dashes and the CRLF at the end of the bytes of your file, and then saving that file with 4 extra bytes to your hard drive. That's not exactly what the image should be, and it can, depending on some factors, it can corrupt the entire image because the JPEG format isn't expecting those extra 4 bytes hanging out at the end. The last one also has a trailing dash dash. So some of you like to split on which actually you probably should do this. There's nothing wrong with this one at all. But splitting on the boundaries, when you split on boundary, you will have an extra split at the end that's just dash dash. So handling that, however you're going to handle that, is something you have to do. There's going to be a trailing dash dash at the end and trailing CRLF after this as well. So make sure you don't have those extra 4 bytes. Don't try to treat those as an image, or don't try to parse the headers in the body of that, treating it like a whole extra part. You have to ignore that last split if that's the way you're parsing this. So just be aware that that's there. And then once we extract the part, we split on these boundaries. And I forgot to say, it was on a bullet point, but the browser will guarantee that the boundary is not contained in any of the actual data that we're sending. The browser is responsible for doing that. It has to do that to be able to fit the protocol. It has to make sure that that boundary doesn't exist anywhere in this content. So we can safely split on the boundary and get our separate parts. Once we have our parts, and we have the part that contains the image, which will be the only part for your homework, we have any number of headers, a blank line, and then the actual content itself. These headers can contain, I want the next slide, can contain content type. Oh, the next slide after this one. They can contain content type, though. Next slide. Hang on to that thought. They will contain content disposition. And this is where we're going to get the name of the input on the front end. So we have that input named commenter and an input named upload. That's where the name's going to go. So this is how you can tell which part corresponds to which part of the form. Again, for your homework, to limit the complexity, there's only one part. So, you know what the content disposition is going to be for the most part. And then the file name that the user had, the name of that file on the user's machine. This information is pretty much garbage. We don't want to use the user's file name. We don't care what the user named their file. We're going to replace that with your own naming convention. We really can't use this. Like, you might want to save the file with that file name. But what if 2 users submit a file with the same file name? Now you have a naming conflict. Things can get messy real quick. Maybe you want to keep track of that information for some reason. You could store it in a database. For our homework, we don't care at all. You're going to use your own naming convention for your file names. But that's part of the information you're going to get in the content disposition of a file upload. And then, okay, we can talk about content type. The content type is optional. If content type doesn't exist, the content type is text/plain. So it's just plain text. This was just text that the user typed into text input. There's no content type, so we know that that's just plain text. If it's not plain text, the content type will be specified. So this was a PNG. I got content type of image PNG. And there's no content length. Each part does not have content length. So we have content type, at least either explicit or implied, but we will not have content length in these parts. The reason for content length in an HTTP request is to know how much content needs to be read. We have this TCP socket. It's an open connection, and we got a bunch of bytes sitting there on this connection waiting to be read. And we need to know 2 things. One, did we read the entire request? So we look at the content length, and that tells us how many bytes are in the body. And we need to read from that socket until we read that many bytes to make sure that we have the entire request. And 2, make sure we don't have another request. This isn't something we do in 312. Maybe in a future semester sometime I'll add this. I thought about adding it this semester, but then didn't. We can reuse a TCP connection for multiple HTTP requests. That keep alive header, that's what that means. It says, keep this TCP connection alive for future HTTP requests. So we want to know when we read from our buffer, did we get part of the next HTTP request in this receive, in the bytes that we read? Because if we do, we want to set those bytes aside and then process that request later. But right now, we got to process the first request. So did we overshoot the content length? If we overshot, we have another request that we kind of spilled into. So we need to know those 2 things. Neither of those issues exist in the part of a multi-part request. The whole thing was already read. We already have the entire request, so we don't have to worry about reading all of the bytes of the body. We already have them all. We know we have them all because of the content length of the request itself. And we don't have to worry about spilling into the next part because we already have the boundaries which told us when exactly the part ends. So neither of those two issues are a problem. So we don't need content length, so we don't put content length. Or rather, the browser doesn't, the spec doesn't. There's no content length in the parts of a multi-part request. We only need it once and it serves its purpose. Don't need it again. Never, I think I've harped on this plenty this semester, but never, ever, ever convert the bytes of a file into a string. You're going to corrupt everything. You're going to corrupt the file. It's not going to work the way you want it to. Yeah?
Would we ever have a problem where when we're buffering, like half of the buffer would be one part of the form and the other half would be another part of the form?
Yeah. Mm-hmm. Yeah, but you don't even look, when you're buffering, well, I'll talk about this in buffering lecture, but when you're buffering, you don't even care what you're reading at that point. You don't process the body until you have all of the content. Then you stop buffering, then you start processing the body. So that situation wouldn't cause a problem. So never ever corrupt the bytes of your file. You need to do this without converting it to a string. How do we do this? This is going to spill into next lecture, which is fine. Next lecture has some wiggle room. But never, ever convert this to a string. So how do we do this? We're going to start by parsing in bytes instead of strings. We did a lot of string parsing so far. We're going to get into byte parsing at this point. Good news is Python makes this actually pretty seamless, pretty painless. You've already worked with byte strings. You just do dot encode. It converts a string to byte arrays. And byte arrays in Python work a lot like strings. You have the in method. You have split. You have a lot of the niceties that you would want when doing byte parsing. So Python makes this transition from strings to bytes not too difficult, but this means you have to encode everything into bytes and work with your byte arrays and just never convert them into strings unless you know, absolutely know what you're working with is text data, which is the headers. The headers you know are going to be text. It's only ASCII allowed in headers. So if you know what you have, a sub-array of your bytes that you've read is only headers, you can safely decode it, convert it to text, and handle it in a text way. So to do that, you look for your first, to answer the question. When I say CRLF, I mean /.